Okay, in this video, we are going to go beyond the beat and learn some things about basic recording, some super simple physics, and some things about gear and what you need in order to make it happen. First, to define some terms. What is sound? What is audio? You know, whenever we talk or bang on a drum or strum a guitar, we are creating vibrations in the air. We are disrupting the relative calm of silence. These vibrations are called waves. Audio, or these waves, are measured on an XY axis, where the x-axis is frequency and the y-axis is the loudness or amplitude of our signal. We will probably get into that more, but I want you to know that the wavelength is the amount of time or the frequency from on the x-axis, the zero crossing, of an upward trajectory wave to the next crossing of the zero crossing or x-axis going up. All right, so this amount of time is called a cycle, and the more cycles there are over time is a higher frequency. The longer the cycle, the lower the frequency. So low frequencies are longer wavelengths, higher frequencies are shorter wavelengths or shorter cycles. Amplitude is the volume or the loudness of a signal. We measure it in decibels, and that's on the y-axis. So when you see a short waveform over the x-axis, that means that it is quiet, less air pressure, less volume, and the higher peaks of your vertical waveforms, the higher the volume. When we are capturing or recording audio from the analog domain, the domain of vibrations, to the digital domain, the domain of zeros and ones, we consider two parameters in terms of quality: sample rate and bit depth. The sample rate, and let's take a look at a Pro Tools session just to put this into perspective. When we are creating a session, we have parameters here of sample rate and bit depth. Sample rate goes from 44.1 kilohertz all the way up to 192. So this is thousand, so 44.1 thousand, 192,000. And then we have 1624 or 30-bit float, which we won't get into. So sample rate, I always have thought about this. It is the number of samples per second, but if you think about it as the number of photographs taken of a particular sound per second. So the more photographs, the better coverage you're going to get of that image. Think about pixelation when it comes to visuals. So we're talking about 44.1 thousand or 192,000 pictures per second. That is measured in hertz. Kilohertz is 1,000. And look at these rectangles, because that's where bit depth and visualizing bit depth is helpful. Bit depth refers to the number of bits per sample. Think graph paper. It's the amount of digital quantizing or rounding. And we can even go as far as to say, a waveform in analog world is rounded, but we can't get there digitally. But we can kind of round up and interpret and fill these gaps through a higher bit depth. So the higher the sample rate, you're already kind of getting closer to a clean curve. But when you add more squares or more bits, then you can kind of quantize less. So the grainier the sample, the bit depth, you're going to get kind of this squaring off kind of thing, because you're unable to, well, you can, but you're going to introduce all kinds of aliasing perhaps or noise. But you get a nice and cleaner waveform with a higher bit depth and a higher sample rate. Now, sure, higher is better, but you got to consider a few things. The higher, it's going to take more disk space. Disk space is not expensive these days, but it's something to think about. CD quality, which is 44.1 kilohertz 16-bit, takes 10 megabytes per stereo minute. So a 3-minute song is going to be 30 megabytes. Audio that's at 192.24 takes 66 megabytes per minute. What is that, like 190 megabytes for a 3-minute song? Don't quote me on the math there. Not all software works at all of these resolutions. Not all A to D converters or your audio interfaces work. So, what do you need for basic recording? You need a microphone, or 10 if you're going to do a drum kit. Microphones convert the vibrations of sound into an electrical signal. They do, we'll leave it at that. A microphone preamp you need because the mic goes into the preamp in order to amplify. Microphones put off very, very low level electrical or very low amplitude. So we need to amplify that level so that we can do something with it. Then we need an analog to digital converter. We need to take that electrical signal, those vibrations, and convert them into the zeros and ones of the digital domain. We need to listen to what we're doing, so we either need some headphones and or some speakers to hear what we're doing. And especially we need headphones when we're recording, because we don't want any music that we're listening to, if we're singing or rapping, what have you, to go into the microphone and cloud things up. We want a clean recording. And of course, we need a computer and some software to capture, edit, mix, and output our music, our audio. So this Focusrite Solo is what you have at all your desks. It is an all-in-one solution. It costs about $115. It will get you what you need. This Shure SM58 is about $100. These are better headphones than you all have at your desk. These are about $100. The ones at your desk are about $20. Do they sound the same? They do not. And, so basically this setup, I could probably say minus the computer, you're looking at $300. With the computer, maybe 15. Does quality matter? Nice shoes, nice food, nice car tends to cost a bit more. So closer to what we have in the studio, a condenser mic. This is a TLM 103, about $1,000. Is going to capture a wider frequency. It's going to introduce less noise, a number of things. It's going to have a different frequency response, hopefully flatter than a small SM58 or a small diaphragm dynamic. This preamp, which is a 2-channel preamp, you have 1 and 2, is going to give you more headroom or more amplitude that you can bring your microphone up to level. It is going to be quieter. It will have different colorization or less coloring than a cheaper preamp. You're going to have a separate A to D, D to A converter that is going to do your conversions at a higher quality, or in this case, this is called the Pro Tools HD I/O. This gives you 16 inputs and outputs, while your Solo only gives you 2 inputs and outputs. So you can record a full band on this. You can put them together and have 32. So much more flexibility, much larger track counts, etc. You're going to have a bigger computer that gives you the ability maybe to install PCI cards or additional hard drives or much more RAM than you could in a closed architecture computer or laptop. Some more speakers and some headphones, maybe some nice and all of these, you're going to find microphones from $100 to $10,000 preamps from $1,000 or $100 to $10,000. It just is about trying to have the best signal the entire chain that you are building. And I think that will cover audio.